Okay, this is factor and find the roots, but it has more than one root. Most of the ones that are from your textbook have really nice roots, so you can figure out when you've made a mistake or not, because this should look very nice. So in WebAssign, they have this question as different ways. They ask you to factor it, or they ask you to find the roots. It could be a multiple different ways that they ask this question. And I feel a little guilty, actually, showing you synthetic division, because I have all high school teachers in my night class, and one of them said it's really, really important to do long division with students. And I thought, yeah, I should know that, because in Calculus 2 you need that. And but I've already done synthetic division, so I'm not going to stop doing it here, but it was important for me to have done it by long division. They're really good high school teachers. They're fantastic. Yeah. Got it?
Yes.
Right. So, that's what it looks like. I always get worried when I look at a graph like that, because when I look at a graph like that, what does it tell me about my screen? Do I got the whole graph? No, because when those pieces on top are cut off. So how could I see the whole graph? Zoom out. So just to make sure, because what if it goes around and has a root somewhere back there? I won't see it. Or it goes over to this side, outside of the default window, and has a root. I won't see that either. And I don't know if that's happened to you, but that can easily happen. So you want to zoom out. From here, there's two roots that I can see. Looks like one is at -2 and one is at 2. Just eyeballing it without even the trace button, I can see that. But I just wanted to make sure, so I zoomed out, and it freaked out too, and it gave me this wild-looking graph. But it really shows me that there's probably only 2 crossings. It freaks out like that because when you go back like that, it still takes a 10 by 10 grid of points, so it's not sampling enough points to put the lines through it. And look at it, looks all liney here. That's because it's actually connecting those points with lines. But on this part, when I have you graph it, I'll ask you for the resized windows. Did you make sure you got all the graphs? So I'll ask you for those impromptu so you're sure that you know what to do here. So analytical work, that's the part you do with the algebra. Well, how could you not use it? You already know the roots. There's actually a process to find each one of the roots with P's and Q's. You probably did that in Math 100. We're going to skip that because we already know one of them is probably 2 and one of them is probably -2. I initially made a mistake with synthetic division. I want you to find it. So I'm going to go through that next few slides. So here's what I did. I lined up all the coefficients, 1, -3, 4, -32, and 48. And I started down the path. And I got up to here and I knew what was wrong. Hold up. Hold up. Something's wrong. And I know it's wrong because 2 times -28 is not -48, and it's supposed to have a 0. Krishna? Right. So I looked at that and went, my calculator isn't wrong. I'm never wrong. I'm a mother. I'm never wrong. So what was wrong? I missed, there's an x squared term here, so there should have been a 0 coefficient between 4 and -32. And that would make a difference. So, I mean, it's really nice to have the calculator because if you didn't have it, then you'd look at this step and go, what's going on? But now I already know the answers too because I saw it on the calculator. I was staring at my calculator little window and I knew I typed it in right. So the only possibility is I must have done something wrong in the analytical work. And that was it. There had to be a 0 there for the x squared term. Now we go. 1 goes down. 1 times 2 is 2. Add them, you get -1. -2, add it to the 4, you get 2. 2 times 2 is 4. Add it to the 0, you get 4. 4 times 2 is 8. Add it, you get the 0 at the end as it should be. Whew. Students who take the general education math, I used to survey them every semester, and they said they hate math because they feel you have to be perfect. And I thought it was such a strange thing for students to say, because I'm definitely far from being perfect. But I realized over time the reason they felt they had to be perfect is they were marked wrong when they got things wrong on the test. But someone should have taught them that everybody makes mistakes. It's being able to find it and figure out where the mistake is and hunt it down. So right like that, I just made a mistake, I showed it to you. I knew I was wrong, I showed you how I knew I was wrong. And I kind of logically went through where the mistake must have been. That's the skill, not being perfect. Thank God. So I just copied and pasted the slide here. This is where we are now. So they wanted you to factor it. Well, here's x minus 2 comes out, and these are the coefficients that I got from pulled off on the previous thing. Now this thing's got to be synthetic divisions also. So I have to move this thing through synthetic division as well, because I have more than one root. Well, I know one of the other roots too. It's -2. So I'm going to go through the synthetic division motions, not slowly this time, and I get this. I copied and pasted so you can see that. And I know that last piece has no more roots. Why? Because I already saw it on the calculator, but I also know it doesn't have more roots. There's ways to see that with the P's and the Q's and testing all possibilities. On your test, you're allowed to say, I only saw 2 when I zoomed out. The zoom out is what tells me there's only 2. I saw the full graph, and there was no more crossings. Right? The other thing is a lot of busy work, because you have to take all the coefficients and then multiply and make sure that you have try every piece and that you don't get 0 as an answer at the end. And you guys are looking at me like you remember this, so Math 100, I'm sure you did that. But we're done. That thing has no more roots, and that's all the factors. And by the way, this is confirming that x equals 2 and -2 are roots.
When you zoomed out, did it look like it didn't touch the 2?
Right. The reason is the way, I'm not really sure how your calculator samples, but what it's doing is it's plotting points. So it'll take your grid, however you make it, with minus 10 to 10, it'll make 10 x points that it'll sample the y points and then connect the dots. Right? So if you zoom out, it's still doing 10 this, but except now you're going from minus 100 to 100, let's say, and 100 to 100. 10 is not enough, so it's connecting a dot and not going down far enough to connect the dots and see that it has a root over here.
Because when it was zoomed in, it looked like it touched the 2.
It did. If you want to get precise answers, you zoom in. And you can change the setting on your calculator to force it to actually sample more points.
So it did touch like
I think it's the XCR thing that's on your Windows. You tell it to actually sample at more points.
Okay, but it did touch.
Yeah, absolutely, yeah. When you zoom in, it touches.
How did you get execution? Was it the opposite of -2?
No, I saw it on the graph, on the original graph. -2 is a root.
No, I'm talking about x plus 2.
I know that this is the form because x equals -2 is a solution to this.
Okay.
Right, that's how I know. Okay, Jennifer was asking about this x plus 2. How did I know it was a factor? Because -2 is a root. And x plus 2 equals 0 gives you the root of -2. That's how I know it's this. All right, any other questions? Okay, Wednesday, everybody come here, tour de force, make sure we siphon off our territorial area so that other students can't come in front. And send me your questions. Text them to me or email them to me. Use this guy as much as you can. He's Montclair State alum. Get everything out of him that you can.